All right, so today we're going to just keep talking about solving our trig equations. They're going to be get a little bit more complicated today. Last time we talked about solving some very basic equations, just adding and subtracting from both sides, dividing into both sides, getting our trig function by itself, and then kind of thinking through how to get the angles that we need. So just more equations today that are going to involve our quadratic equations, right? And like last time, we tried to sort of equate that or relate that back to our algebra type equations. And we'll do the same thing here, right? So for example, if I gave you an equation like 5x squared minus 20 equals 0, right? How would you want to go about solving that? Well, hopefully you remember from algebra class that all you got to do is add the 20 and then divide 5 with the whole purpose of getting x squared by itself, at which point we can square root both sides to get x. And the square root of 4 is 2, but don't forget that when you square root in an equation, you have to include a plus or minus. Because obviously positive 2 times positive 2 is 4, but so is negative 2 times negative 2. So this is called the square root method, right? We can do that here. And the reason why we're allowed to do that is because the only variable that we see that we're trying to solve for is being squared. If there were an x to the first in there, then we would have a problem. We couldn't do it this way, okay? But we can here. So how does this relate to our trig functions? Well, if we replace this x with a trig function like sine of x and make that sine squared, then we still do it the same way. Just get our sine squared by itself and then square root both sides and go from there. So, for example, like this guy, right? So just like our first day of notes, we still want our solutions to be between 0 and 360 inclusive, right? So 0 and 360 are both going to count if we think that those need to be part of our solutions. All right, so like we were saying, we're going to treat our trig function like a giant variable. So cosine squared, I need to get that by itself so that I can square root both sides and work my way towards some solutions for x, right? So it means all I got to do is divide by 2. We get cosine squared x equals a half, right? Now, just square root both sides. So cosine of x is going to be equal to, remember to put in your plus or minus. And then we get the square root of 1 over 2. Now, we did talk about not rationalizing or simplifying anymore if we don't want to, but if you don't do that here, you might lose sight of the fact that you're looking at a unit circle value, right? So if I split this radical up, I get the square root of 1 over the square root of 2. And I want to keep working on reducing this. The square root of 1 is 1. So I get 1 over radical 2. Well, I can rationalize by bringing the radical 2 up and leaving the 2 in the denominator. So now what that means is I'm looking for angles whose cosine value is radical 2 over 2. That's definitely a unit circle value. Now, next thing, we need to do our quadrant analysis like we did last time. Right, so the first question is what quadrants is cosine positive, right? And cosine is positive in quadrant 1 and quadrant 4. Now, where is cosine negative? Because remember, cosine can also be negative radical 2 over 2, which is different than last time. Well, cosine is negative in quadrant 2 and quadrant 3. So we're actually looking for an angle in all 4 quadrants. Right, which is a little bit strange, but it's because we square rooted in an equation and we have to include our plus or minus. We have to include the positive and the negative side of that result. Okay? All right. Luckily, the value is the same, just the sign changes. So the question is, where is cosine radical 2 over 2? What angle is cosine radical 2 over 2? And that angle is 45 degrees. So, like last time, that's going to become our distance from the horizontal in every quadrant that we need an angle from. And for right now, it's all 4 quadrants. Now just use your quadrant rules to get you into your solutions, right? In quadrant 1, we just use the distance as our solution, so 45 degrees. In quadrant 2, we take the distance and subtract from 180, so we get 135 degrees. In quadrant 3, we take 180 plus our distance, which is 225. And in quadrant 4, we take 45 from 360 and get 315. So there are our solutions. Okay? And so again, we're just getting cosine squared by itself. We square root both sides, just making sure that we include the plus or minus, which adds some additional solutions that we have to go find. All right? Next one. Next one looks like this, right? So 2 tangent squared minus 3 equals 0. But it's the same thing. The only tangent that I see that I want to try to get by itself is being squared. So just work on getting tangent squared by itself and square root both sides. Probably the first thing we're going to want to do is distribute that too. So let's go ahead and do that. And then we're going to add 6 and divide by 2, which I'm just going to do all in one step to get tangent squared of x equals 3. Then we square root. We get tangent of x equals, don't forget your plus or minus, radical 3. So that means that tangent can be positive radical 3, or the tangent of this angle can be negative radical 3. If it's helpful to separate the signs, do a plus and then a negative to kind of see what's going on, that's fine. But that's what this means. Okay, so our quadrant analysis, we've got to figure out what quadrant tangent is positive in. And those quadrants are 1 and 3. And then we got to figure out what quadrants tangent is negative in. And those quadrants are 2 and 4. So we're back to finding an angle in each quadrant. All right, no problem. Just got to find our distance from the horizontal, which means I need to find an angle whose tangent is radical 3. Remember, tangent is y over x. So what we must have had was radical 3 over 2 over a half, so that when you flip this over and multiply, you got just radical 3, right? That means that the y-coordinate has to be bigger than the x-coordinate, and that happens at our angle that's closest to the y-axis. So in other words, 60 degrees. So that means the distance from the horizontal is 60 degrees everywhere. And so to go find our solutions, and I'll get rid of this little side work here, x is going to have to be 60 degrees. Subtract 60 from 180 and get 120. Take 60 and add to 180, so get 240. And then take 60 and subtract it from 360 and get 300. And so there are your solutions. Okay. All right. One more here for you to try. So try that guy, stop the video, work it out, then you can start it back up and check to see if you're getting this. All right, so there you go. Did you get 45, 135, 225, and 315? Okay, hopefully you did. If not, make sure you find some time to come in and we'll sit down and go through it. Okay, so that's how we can use the square root method. Now, there are times where you came up with two factors, right? So two things getting multiplied together that you used to solve your quadratic equations also. So as long as your equation was equal to 0, right, then we can use what's called the zero product property, right? Do you remember what that was? The zero product property is that thing that says if you're going to multiply two things together, so if you're going to get a product, the product is the answer to a multiplication problem. So this right here on the left-hand side is the product. If that product is going to be equal to 0, like the equation says it has to be, then that means that one of your factors has to be 0, right? So we're going to try to find a value of x that will make that first factor 0. We can probably look and just say that that's going to be -2. If I plug -2 in for x, -2 plus 2 is 0. Well, then I also need a value of x that's going to make this other factor 0. It doesn't have to make them 0 at the same time. It just has to make one of them 0. So negative 2 is going to do that for the first guy. Obviously, 3 is going to do that for the second guy. So we can just look and tell, but sometimes these equations are a little bit more complicated, and so much so that just looking and telling isn't going to be possible. So if we need one of our factors to be equal to 0, if we need one of our factors to be 0 in order to use the zero product property, then one way we can find out how to do that is to take our factors and set them equal to 0 and solve. Right? Which is a whole lot of background into why we do what we do, which is basically if you've got two factors that are going to be multiplied together and have to be equal to 0, then just take your factors, set them each equal to 0, and solve and see how that happens. So your two solutions here would be negative 2 and 3. But again, if you replace x with trig functions, the same rule applies. I would still need those factors to be equal to 0. For example, like this, right? I'm supposed to multiply cosine and 2 sine plus 1 together. And when I do that, I need to get an answer of 0. I need to get a result of 0. The only way that happens is if cosine of x, the value of cosine of x is 0, or if 2 sine of x plus 1 is 0. So I set them equal to 0 and find out what angles make that happen. Well, the cosine one is already got cosine by itself, so no additional work needs to be done there. The sine one, we got to subtract 1 and divide by 2, so we get negative 1/2. Right? So, now that we're getting two kind of different values with two different trig functions, I think we need to do some quadrant analysis separately. So I'm going to start doing this separately. I didn't do it before because even though there was a positive and a negative, the values themselves were still the same. So it just made sense to keep doing the quadrant analysis together. But here they're going to be two different, so I'm just going to separate them out. So where is cosine 0? Well, cosine is 0 at 90 and 270. So two of our solutions are going to be 90 degrees and 270. All right, now the other one. Got to figure out where is sine negative. Well, sine is negative in quadrant 3 and quadrant 4. All right, I need the distance from the horizontal then. So I'm going to kind of put a dotted angle in here in quadrant 1 because I'm really just going to try to figure out what angle is sine 1/2. And that angle is 30 degrees. So that means that my distance from the horizontal in the two quadrants that I need angles from is also going to be 30. And that's going to help me find the angles that I want as solutions. So if I add 30 to 180, I get 210. If I subtract 30 from 330, if I subtract 30 from 360, I get 330. And so there are two more solutions. So we want 90, 270, 210, and 330. Okay, so if we can come up with two factors that are supposed to be equal to 0, then just set your factors equal to 0. Now, that's only going to work if the equation is equal to 0, so make sure that that's true before you try to split these guys up. Okay, so next one looks like this. So again, I've got two factors. This guy and this guy are being multiplied together, and they're supposed to be equal to 0. So take each factor, set them equal to 0 to find out how to make that happen. Okay, so solving for each little equation. In the first one, cosine theta, if you subtract radical 3 and divide by 2, is negative radical 3 over 2. In the second one, if you subtract 1 and divide by 2, you get negative 1/2. So I'm going to do my quadrant analysis separately for these guys. And find solutions separately, even though I know that they're all going to be like solutions to the same equation. All right, so where is cosine negative? Well, cosine is negative in quadrant 2 and quadrant 3. That means, again, to find my distance from the horizontal, I just need an angle whose cosine value is radical 3 over 2. And that's 30 degrees. So that means my distance from the horizontal in the two quadrants that I'm looking for solutions in is going to be 30 degrees. And so two of my solutions are going to be 150 and 210. Now the other one. Again, what quadrants is cosine negative? That's 2 and 3. So same deal. I need to know what angle is the value of cosine 1/2, and that's going to be 60. 60 degrees becomes our distance from the horizontal. So for two more solutions, I got to take 180 minus 60 and get 120, or 180 plus 60 and get 240. And there are my solutions. All right. All right. Now try this one all on your own. Then we got to talk about what's going to happen. It's going to freak you out, but we'll figure it out. So there we go. You should have 90 and 270, and then notice that I've scratched out the other one. Because when you type this into your calculator, which you needed to do, right? Radical 5 is not a value on the unit circle. So that means we have to inverse sine the square root of 5 and see what we get for an angle measure. But it doesn't work. Your calculator blows up. It doesn't want to do anything, right? Why is that? Well, if you go back to geometry, trig, right? Go into a right triangle and start thinking about your angle measure. Well, if I wanted to find the sine of that angle, sine is supposed to be opposite over hypotenuse, right? So if I write that out as a ratio or a fraction like I'm supposed to, opposite over hypotenuse. In a right triangle, which side is the longest side? Always. The longest side is always the hypotenuse, right? So that means that when you write sine as a fraction, opposite over hypotenuse, you know that the denominator is always going to be bigger than the numerator. This guy is always going to be bigger. And if the bottom or the denominator is always bigger, what kind of number is that? Well, think about it. 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, right? If that denominator is going to be bigger than the numerator, then this guy has to be a fraction or a decimal. It can't be anything over 1. It's got to be less than 1. Well, if you type in the square root of 5, that gets you 2.23. And that's definitely bigger than 1. That cannot physically happen. So since it cannot physically happen, that means we can't get a solution out of that side of the equation. Okay? Same thing for cosine, right? Cosine is supposed to be using the adjacent length and the hypotenuse. So a cosine is adjacent over hypotenuse. But again, the hypotenuse will always be longer than the adjacent, so that denominator will always be bigger. So that means that this value has to be less than 1. It has to be a decimal or a fraction. So if you ever get a situation where the cosine value is supposed to be outside of 1, like 1 and negative 1. So if it's bigger than 1 or bigger than negative 1, then you can't use it. You can't find solutions, right? Now that's for sine and cosine. Just as a quick look at tangent, remember tangent is opposite over adjacent. And there's no rule that says that one of those has to be bigger than the other. Sometimes the opposite will be bigger, and sometimes the adjacent will be bigger. So for tangent, this rule doesn't apply. Tangent can have any value it wants. But sine and cosine have to be between negative 1 and 1. They have to be decimals or fractions, or 1. Okay? So anytime you come across a sine or a cosine value that's supposed to be bigger than 1 or larger than negative 1, then you can't use it. So that's why we're left with just these two as your solutions. Okay? Not because radical 5 is not on the unit circle. That's not why. It's because radical 5 is a number bigger than 1, and we can't use it. Okay? All right. So a little wrinkle there. We wanted to explain why that was the way it was. Okay, so hopefully that makes enough sense. If not, come back in and see me and we'll figure it all out. Okay, now, last type of equation for this, quadratic equation, right? If we have a situation like this where we still want to try to solve for x, but now, unlike the first section where we had just an x squared in the equation, now we have an x to the first, which means it doesn't make any sense anymore to get x squared by itself and square root both sides, because if you do that, you're going to have an x in the radical, and that's not going to work. Okay? So, what do we do? Well, we had factors already in the last section of notes. Here we want to come up with our factors. We can factor that down. That trinomial can factor down into two binomials. Remember how to do that? Now, this equation still has to be equal to 0, because as you can see, we're going to create two factors, and I want those two factors to multiply together and give me 0. That way I can use that zero product property and set my factors equal to 0 and go solve. Okay? So, factor. We got to factor down 2x squared. The way we do that is by 2x and x, no choice there. Now we got to come up with factors of negative 15, where if we put those in the parentheses, our smiles will add to negative 7, right? When you think about this for a little while, you try to come up with those factors and place them and make sure that they're right. But if you put in negative 5 with the x and plus 3 with the 2x, then check out your smiles. Negative 5 times 2 is negative 10x. 3 times x is 3x. If you add those, you get negative 7. So that's how you want to factor down that trinomial. And once you have it factored down, these are the factors that you're going to set equal to 0. And then continue solving for x. Add 5 to the right side guy, and then subtract 3 and divide 2 into the left side guy, and so these are your solutions. Right? So factor, set your factors equal to 0. Well, nothing changes if those x's come out and you put in a trig function like sine or cosine. We're going to do the exact same thing. We're going to factor down into two binomials and set those factors equal to 0. Or factor, right? Factor somehow. And remember, the first step in factoring is always looking for a GCF, right? So like this guy. Okay? So sine squared, there's a sine to the first, so I can't get sine squared by itself and just square root both sides. So I got to try to factor. And the first thing you always look for is a GCF, and both these terms have a sign in it. So factor out a sine. I pull sine theta out. When I do, in the first term, if you pull a sine theta out, you're going to be left with the sine theta, so 2 sine theta. And then with sine theta, if I pull a sine theta off of it, I'm going to have to leave a 1 behind, but there's no sine theta there anymore. So those are your two factors. So now we're going to take sine theta, set it equal to 0. And we're going to take 2 sine theta plus 1 and set it equal to 0. So separate little equations. I want to go through and come up with my solutions separately. So that means quadrant analysis and all. So first question, where is sine 0? Well, sine is 0 here and here, which means that my first set of solutions are going to be 0, 180, and 360. We definitely want to use 0 and 360. That's in our interval. The other one, subtract 1, divide by 2, and sine theta is going to be equal to negative 1/2. So a quick quadrant analysis there. Sine is negative in quadrant 3 and 4, which means that I need to come up with an angle whose sine value is 1/2. And that's going to be 30. And that becomes my distance from the horizontal. Okay? So to come up with the rest of my solutions, I'm going to take 180 plus 30, which is 210. And I'm going to take 360 minus 30, which is 330. And so now I've got all of my solutions. All right. Next one. Funny math meme. You can pause and read it, but we're going to keep moving. Okay. All right. Next one's like this. So so I can't use the square root method because there's a cosine to the first. The equation needs to be equal to 0, which it is, so I can use that zero product property. And then I've got a factor, right? So can I factor out a GCF? Is there a GCF between those three terms? And no, there's not. So I've got to break this down into two binomials, two parentheses that I'm going to set equal to 0 in a second. So how does it look when you factor that? Well, just like if that cosine squared was an x squared, and we'd factor that into 2x and x, do the same thing here. 2 cosine squared is going to factor into 2 cosine and cosine. Now I've got to factor down positive 2 so that my smiles will add to negative 5. And after trying some stuff, you end up making this a negative 2 and this a negative 1. So that you get negative 4 cosine here and negative 1 cosine here, which is negative 5. Okay, great. Now take those two and set them equal to 0. Add 1 divided by 2, cosine of x is equal to 1/2. Add 2 and cosine of x is equal to 2. That's a red flag. Can cosine be bigger than 1? No. So we can't use cosine being equal to 2. So we forget about that guy. Okay. Instead, we look at the other one. Quick quadrant analysis. Where is cosine positive? It's positive in quadrant 1 and quadrant 4. All right, what angle has a cosine value of 1/2? Well, that's 60, right? Which means your distance from the horizontal is 60. Which means that your two solutions are going to be 60 degrees, because that's in quadrant 1. And because of quadrant 4 rules, we're going to get 300. Those are your only two solutions. Okay? All right, so here's one for you to try. As a matter of fact, the rest of them are for you to try. So each time, stop the video, work out the problem, start it back up, and make sure that you're getting the solutions that you need. Okay, and I'll make sure I'll explain anything that maybe looks a little bit weird. So try this one. Did you get this? Right, so factor into sine theta plus 3, sine theta plus 2. But when you set those factors equal to 0 and try to solve those, you're going to get sine theta equals negative 3, sine theta equals negative 2. Both of those are outside of our negative 1 to 1 interval, right? In other words, they're not fractions or decimals, so they're numbers bigger than 1, however you want to look at it, but we can't use either one of them. So this is a situation where we have no solution, okay? All right. Next one looks like this. So again, you've got to make sure that your equation is equal to 0 so that we can use the zero product property. But outside of that, you should be able to go ahead and solve this guy. So stop the video, get it going again once you're done, and make sure that you are correct. Right? So did you get this? Right? You can't use the sine of x plus 2 because it's going to give you a sine value that is not between negative 1 and 1, right? It's going to be outside of that, okay? But the sine of x being 1/2, we can use. We get 30 and 150, okay? All right. Next one looks like this. We got 2 more, so try this one. Again, stop the video and then start it back up to see if you're right. All right, so did you get this? So check that out. Make sure that you did factor out a tangent at first, right? Those two both did have a tangent on them, so you can still factor that tangent out and be left with radical 3 minus 2 sine theta and go from there. Okay? All right, last one. Try that. Stop the video, start it back up, and see how you did. And did you get 303.7, 123.7, 63.4, and 243.4, right? Both of these factors, when you set them equal to 0 and try to get x, you're going to have to use inverse tangent, right? Neither one of these values are values that are on the unit circle. So Use the inverse tangent, type them in, get your angles, and make sure that you're thinking through distance from the horizontal, right? If you didn't get that, find some time, come in, and we'll walk through it, all right? Homework out in Canvas. Make sure you have that done by next time.